Today we are going to go into the topic of probability. Probability can be a very complicated topic, but we are just going to go over the basics of it today. Some vocabulary you should know before we get into some of the details is what an event is, what an outcome is, and what probability is itself. An event is something that happens, or like an experiment. The outcome is the result of the event, and probability is the likelihood of something happening. So the probability of an event happening is said to be the number of ways it can happen divided by the total number of outcomes. So this would be like if it were represented in a fraction. Okay, so for example, the probability of flipping heads on a coin toss is that there's one way of flipping heads out of two possible outcomes. You could either flip heads or tails. So we say the probability then is 1 out of 2, or 50%, or 0.5. The probability of something happening will be a fraction or a decimal between 0 and 1, or a percentage between 0% and 100%. Why? The lowest likelihood of something happening is between a 0 chance out of any number total outcomes and a 1 out of 1 chance. Or if you had, let's say, 50 total outcomes, you could have 50 number of ways it can happen out of 50 total outcomes. So 50 out of 50 would be 1 over 1, or a 100% chance. In probability, we have theoretical probability, and we also have experimental probability. Theoretical probability is how likely an event is to occur in theory or without conducting an experiment. So it's a little bit more mathematically calculated. Okay, so for example, we found that the theoretical probability of flipping a heads on a coin toss is 1 out of 2, or 0.5, or 50%. Experimental probability, on the other hand, is how likely an event actually occurred in an experiment. So for example, if we flip a coin 20 times and we calculate how many times we flipped heads on our coin toss, would be an example of experimental probability. So let's say we did this experiment, okay, and then after flipping the coin 20 times, we found that we got heads 12 times out of the 20. Okay, so we would say then that our experimental probability is 12 out of 20. Using experimental probability, we can also calculate future probabilities. So if we say I flipped 12 heads out of 20, and I wanted to know how many times would I flip heads if I tossed a coin 100 times, this is just a simple ratio problem. Okay, so if I flipped the coin 100 times, I would expect to get heads 60 times based on experimental probability. Okay, I found that simply by multiplying 20 by 5 to get to 100 and 12 by 5 to get to 60. So experimental probability is 60 out of 100, whereas my theoretical probability is 50 out of 100. We commonly have a specific notation for calculating the probability of something happening, and that notation is having the word probability or just the letter P, and then in parentheses we have what we are testing, okay, and then we have equals, fraction, decimal, or percentage. Okay, so for example, we have the probability of heads is equal to 1/2, or the probability of heads is equal to 0.5, or the probability of heads is equal to 50%. We can use tables and trees to help us calculate theoretical probability. We will go into more specific details on this in just a moment. So for example, let's say we rolled one 6-sided die and flipped one coin, and we wanted to find the probability of rolling a 3 and flipping a tails. So if I made a table to figure this out, I have one column based on what I'm rolling on my die, and then I have another column based on what I am flipping on my coin. Okay, so I could roll a 1 and flip a heads, roll a 1 and flip a tails. Okay, so then I would get an outcome of 1 and heads, 1 and tails, and so on. Okay, so I have a total of 6 sides on my die. So that's why the number goes from 1 to 6. And then since I have 2 options, or 2 outcomes for my coin flip, I'm having heads and tails for each die roll. Okay, so after I calculate my outcome, I see that I have 12 total outcomes. So there's 12 outcomes here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And only one time where I'm going to have a 3 and a tails. So I have one chance out of 12 outcomes. So that's how I got 1 out of 12, which is also equal to 0.0833 or 8.33%. We also commonly use trees to calculate probability. So in this example, we are calculating what is the probability of flipping 2 coins, one after the other, and getting a heads and then a heads. Okay, so this part here on our tree represents the first coin flip. So we can get either the heads or the tails. Okay, and then on our second flip, we can also still get only heads or tails. Okay, so when we calculate our outcomes, we're just putting these parts together. So our outcome could be heads and heads, heads and tails, tails and heads, or tails and tails. If we go back to this problem from before, I could also make a tree instead of a table, which would look something like this. Okay, so I can roll a 1 through 6. So 1, 2, 3, 4, 5, 6. Okay, and then for my coin flip, I can get heads or tails. Heads or tails. Heads, tails, heads, tails, heads, tails, and heads, tails. Okay, so I can list out my outcomes again with rolling a 1, flipping a heads, rolling a 1, flipping a tails, and so on. And when I want to calculate my probability of getting a 3 and a tails, I see in my tree that I just have one time where that's going to happen out of 12 possibilities. In probability, we also have an independent event and a dependent event. So an independent event is when the probability of a second, third, etc. event is not affected by the previous event. We will go into more examples in just a moment. A dependent event, on the other hand, is when the probability of a second, third, etc. event is affected by the previous event. Again, we will go through more examples in just a moment. Okay, so some examples now for independent events. Let's say you want to calculate the probability of rolling a 3 on a die and getting a tails on a coin flip. Okay, so we already calculated that the probability of rolling a 3 would be a 1 out of 6 chance, okay, because you could roll a 1, a 2, a 3, 4, 5, or 6. So 1 out of 6 chance of rolling a 3. And then for flipping a tails, we have a 1 out of 2 chance, because you could either flip heads or you can flip tails. Okay, in order to calculate this chance or this probability of rolling a 3 and a tails, you're going to just multiply the probabilities together. Okay, so in order to do that, we're just going to multiply 1/6 times 1/2, and that's equal to 1 out of 12. So there would be a 1 out of 12 chance of rolling a 3 and flipping a tails, which is exactly what we calculated back in this problem over here. A very common example of independent events is the chance of parents having biological boys or girls in a particular order. This is an independent event because the gender of the child in each pregnancy, when left to chance, is not affected by a previous pregnancy. Okay, so for example, what is the chance of a couple having 3 children and all 3 children are girls when order matters? Okay, so I'm going to use a tree, and then I'm also going to use the multiplication example that I went over before. Okay, so first, the first child could be a boy or a girl. Okay, so this is your first child. The second child could be a boy or a girl. And then the third child could also be a boy or a girl. Okay, so now if I list out all of the outcomes that this couple could have if they have 3 children, they could have 3 boys in a row. They could have a boy, boy, and then a girl. They could have a boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. Okay, so the chances then of having all 3 children being girls would be a 1 chance out of 8. Okay, so we have 8 total outcomes here, and only 1 chance out of those 8 where the couple is having 3 girls in a row. If I just did my multiplication method of calculating this, the probability of having a girl for the first child is 1 out of 2. The probability of having a girl for the second child is 1 out of 2. And the probability of having a girl for the third child is 1 out of 2. So if I just calculate the 1/2s together 3 times, there is a 1 out of 8. 1 out of 8 chance, which is what we got when we made the tree. Dependent event examples are when you are going to basically be finding the probability of something and then removing that chance from happening again. Okay, so for example, let's say you want to calculate the probability of your name on a popsicle stick getting chosen, and the popsicle sticks are removed when someone gets chosen. There are 20 names on the popsicle sticks. So the probability of your name getting chosen on the first stick would be 1 out of 20, because we're drawing 1 stick out of 20 possible sticks. So that's where we get 1 out of 20. If we remove that popsicle stick, and then we are left with 19, on the second draw, you would have a 1 out of 19 chance of your name getting chosen if it was not already chosen. If we remove that stick that was chosen on the second draw, and we're calculating what your probability is of getting your name chosen on the third draw, we now have 18 sticks, so your chance of getting chosen if you were not chosen is 1 out of 18. Okay, so note that the total sample size decreases after each draw in this example. So in this example, we are subtracting 1 each time from the total possible outcomes after each draw. Okay, we have some example problems here. So number 1, we have, what are the chances that your older pregnant cousin will give birth to a baby girl? So is this an independent event or a dependent event? And then what is the probability of your cousin having a girl? Second problem is you have a bag of marbles, 1 red marble, 2 blue marbles, and 2 green marbles. What is the probability of picking a red marble, not putting it back in the bag, and then picking a blue marble? And then if the math confuses you, make a tree. Okay, so again, we're answering if it's an independent or dependent event, and then we're calculating the probability of a red marble, then a blue marble without replacement. Feel free to pause this video to work through these problems. We will go over the answers in just a moment. Okay, so for number 1, we have an independent event because the likelihood of having a girl is not dependent on a previous pregnancy, so that would be an independent event. The probability of having a girl would be a 1 out of 2 chance, or 0.5 or 50%, because your cousin can have a girl 1 time out of 2 possible outcomes, having a boy or a girl. For question 2, we have a dependent event because we are not putting the marble that we drew from the first pick back into the bag. Okay, so we are going to have probability of the second draw be dependent on the first draw. Okay, so if we draw the marble and we calculate the probability of the first draw, we see that there is 1 marble, or 1 red marble, out of 5 possible outcomes. So we have the 1 red, the 2 blues, and the 2 greens. So add those up, you get 5 outcomes. Okay, so our probability of drawing red is 1 out of 5. And then if we don't put that red marble back, we are now eliminating the red marble altogether from our bag. Okay, so now we have 4 total marbles left in the bag, okay, and we're trying to find the probability of a blue marble. So that would be 2 chances out of 4. Okay, so in order to calculate red then blue without replacement, we would just multiply these together to get 2 out of 20, which is 1 out of 10.